Hi, we are trying this whole video lesson one more time. We're doing it in a different format, so I'm hoping that is going to allow you to pause and stop when you need to. If not, I have had students have better luck if they're having trouble by emailing me, and I can send them the video directly to their email if it's not working off of Google Classroom. So good luck, and I hope you enjoy today's science lesson. It is a super fun one.
Hi, it's Doug. You're looking at Mount Everest, the tallest mountain in the world. Mount Everest and the surrounding Himalaya mountains are so tall that astronauts can see their snow capped peaks all the way from space. Part of what makes mountains so impressive is that they're solid rock all the way through. Like, look, this isn't a mound of individual rocks piled up really high. This mountain is one single solid rock. Mountains are like walls of vertical rock going straight up into the sky. But will these mountains always be there? Do mountains last forever? You might think, well, yeah, why not? But let me tell you a story. A story about not a natural mountain, but a mountain made by people. This, a pyramid, like the kind built by the ancient Egyptians. The Egyptians lived right here, but our story actually takes place on the other side of the world, here, in the jungles of Central America. The people over here made a type of pyramid too, a people called the ancient Mayans. This is the Mayans' most well known pyramid. It's a great temple called Kukulkan, about 100 feet tall. Now, pyramids, unlike mountains, are not one solid piece of rock. Instead, they're built up, layer by layer, brick by brick, using stone bricks that have been chiseled by hand. About 1,000 years ago, the Mayan people abandoned the use of their pyramids. They actually left them and they went to live in other places. Most of their pyramids became long forgotten. In fact, hundreds of years later, people didn't know many of the pyramids were even there anymore. They were lost in the jungle. What happened to the pyramids? How could something that big go missing? About 100 years ago, local residents were traveling through the jungle and noticed this. Do you see it? It's a giant hill covered in trees. There aren't many hills around here, so that's kind of weird. The residents who noticed got interested, so they went closer to check it out. When they got to the base of the hill, this is what they saw. They noticed that weirdly, the trees had been growing in a pile of rocks. So they started removing the trees. And when they did, here is what they saw. This. Look at that. It's the steps of a pyramid. Once they finished removing all the trees, this is what was revealed. It was one of the ancient Mayan pyramids. So cool. So, what happened? Well, here's a close up of one of the trees before they removed it. What do you think is going on here? What do you think happened to this pyramid?
All right, it is time to pause the video and look for the link.
The pyramid's bricks used to look nice and straight, but now they're crooked and some have crumbled. What happened? It seems like the trees were breaking the bricks. Is that really possible for plants or trees to break something as strong as rock? That sounds crazy. Roots aren't that tough, are they? But let me show you something. Here's a whole bunch of solid rock. It's what used to be a lava flow. But the lava cooled, and so now it's solid rock. It's tough. You would think that it would be here forever, but if you look closely, as it cooled, it left some little cracks. Those are its weak spots. Seeds can land in the cracks. And when those seeds get rained on, they grow. Let's look more closely. Imagine a seed that's fallen in the crack of a rock. Now let's imagine the seed grows a little root like that. And the root will grow and it'll grow and grow until it fills up the crack. Notice that the root didn't just get longer, it got wider too. Now the root doesn't just stop there, it keeps growing. As the root grows bigger, it pushes outwards like this until eventually, crack, it breaks the rock, making the crack wider and deeper. Eventually, that section of rock will even split off entirely, creating a new chunk of rock. What you just saw here, scientists have a name for this. They call it root wedging because a root wedges itself into the crack and widens the crack. So, does this explain how large Mayan pyramids found? It was a forest of trees growing on top of a pile of rocks. And when they removed the trees, the inner layer of the pyramid was underneath. So now you can understand what happened. Between every brick is a crack. That's a perfect opportunity for a seed. When the Mayans were around, they probably kept their pyramids looking very nice, sweeping away any seeds that might have fallen into the cracks. But when the Mayans left their pyramids behind, the jungle took over. The surrounding trees dropped their seeds into the spaces between every brick, and the roots grew and grew, breaking up the outer layer of the pyramid. That's why, when the Mayan pyramid was rediscovered, it looked like this, just a pile of rocks with trees growing out of it. Now that we know this is what happens, lots of other Mayan pyramids are being rediscovered. Hike around the jungles of southern Mexico, and you might even be the person who rediscovers one of the old pyramids. The first clue is to look for a pile of rocks with trees growing out of it. Now, you may not be planning any trips to the jungles of southern Mexico soon. Still, you can actually see root wedging happening in your neighborhood. You don't have Mayan pyramids in your neighborhood, but you do have sidewalks. Sidewalks don't last forever. If you look around, you can almost always spot at least one section of sidewalk where there's a small crack that's started to form. Just look for the plant or tree that's causing it. It's root wedging. Like, check this out. Can you tell what's going on here? This tree's roots were so powerful that they actually broke apart this section of sidewalk. Just the same as if someone had tried to destroy it with a jackhammer. Isn't that incredible? And look at this. Here's a brick wall that's been cracked, just like the Mayan pyramids. So, root wedging. It's one way that a large slab of rock, like a mountain or a pyramid, gets broken down into smaller pieces. But it's not the only way.
All right, let's take a moment to get our science notebooks. If you're looking for yours, it's your math notebook flipped upside down. You should have a bunch of papers already glued in there. So we are going to find the next blank page, and we are going to write about root wedging. All right, so in your science notebook, we are going to talk about weathering, and part of that is root wedging. And I'm just going to draw a picture of what's on my computer screen. So here is my rock. Should have drawn that a little better. I'm going to draw my rock in a box. Root wedging. So here's my rock, and it's got a crack in it. That a seed falls in. And that seed, here's my seed, eventually grows some roots that break the rock apart. Go ahead and pause here if you need more time to write.
In fact, one of the most common ways involves something totally other than roots. Consider again this solid slab of rock, like this lava rock, which left some cracks in it as it cooled. Seeds aren't the only things that can fall into those cracks. You see, as it rains, water seeps into the cracks too. And that alone can cause problems. Water? Yeah, you heard me right. Water. Let's look more closely. Here's some rainwater in a crack. Now, by itself, the water doesn't seem like much. But as the year goes on, winter approaches. You know what happens to that water as winter approaches? It freezes. Well, something special happens when water freezes. Do you know what? I'll give you a hint. Have you ever heard not to put a can of soda in the freezer? Why do people say that? Don't put a can of soda in the freezer. Most things, when they get cold, they actually contract or get smaller. But water is weird. Water expands or gets bigger when it freezes. And soda is mostly water. So when you put a can of soda in the freezer, the liquid inside freezes and gets bigger until it splits the can open like this. It can even explode like this one. If your soda's in a glass bottle instead of a can, that's even worse. You don't want glass flying everywhere. So don't put cans or bottles in the freezer. That's why you hear that. But what does this have to do with rocks? I bet you can guess. As rainwater freezes in the crack of a rocky surface, the water expands, which pushes the rock apart. Crack. We call this, you want to guess? Ice wedging, because the ice wedges itself into the cracks and widens them, just like plant roots. So both root wedging and ice wedging can split a big rock into smaller rocks. Ice wedging is even more powerful than root wedging. The cracks get deeper and wider even more quickly with ice. Look at this. Here's a rock that has been broken up because of ice wedging. You see all the cracks? Here's another one. And look, this used to be just one rock, but it got broken down into smaller rocks, into individual pieces. Ice wedging and root wedging break rock down into smaller pieces. If you walk around at the top of a
Let's get ice wedging in our notebooks. When water fills in small cracks or holes and freezes, ice forms and expands, pushing the rock apart. So if this was root wedging, this is ice wedging, and we'll draw another picture of our crack. And if you have maybe a blue color pencil, you can there's our water drop, and it is going to force that apart.
that has been broken up because of ice wedging. You see all the cracks? Here's another one. And look, this used to be just one rock, but it got broken down into smaller rocks, into individual pieces. Ice wedging and root wedging break rock down into smaller pieces. If you walk around at the top of a mountain, you might expect to see only solid rock, but think about it. On the top of the highest mountains, it's often cold, right? Rainwater will freeze. In summer, it might melt, but in winter, it will freeze again. And after all that freezing and melting, the top of a mountain will start to look like this. The surface of the mountain becomes a bunch of smaller, broken up rocks, not all one solid piece. Here's another example of a mountaintop. You see how jagged and cracked all the rocks are? So, what do you think? Will a mountain last forever? Well, look at this. This isn't quite as tall as a mountain, but it's still a giant rocky hill. Look at all those splits and cracks. In a few more centuries, as more roots take hold and more water freezes in the cracks, this whole hill will probably split and fall apart into the sea. So we've solved the mystery. Mountains don't last forever. Root wedging and ice wedging breaks them apart.
What? All right, go ahead and go back to that Google form because there is going to be a question about, nope, wrong way, that.
Root wedging and ice wedging breaks them apart. Soon, we're going to do the activity. I want to get you thinking about what happens to the rocks next. You see, once rocks break away from a solid mountain, that's just the beginning of their story. Some of the rocks will tumble down the entire mountainside. They'll get washed away by rainstorms, rolling farther downhill. Maybe they'll fall into a river where they'll get tumbled along, crashing against other rocks. On this long journey, do the rocks get changed in any way? How could we investigate? How could we find out? What happens to a rock once it's broken away from the mountain and now begins to tumble downhill? Try to think of some experiments you could do to figure out the answer to that question.
You guessed it. Go ahead and go to your Google form and find the question that matches. Can you think of some experiments you could do to figure out what happens when a rock tumbles downhill? Pause this video until you're ready to move on.
In this activity, you're going to use sugar cubes in an experiment to see what happens as rocks tumble down a mountain. Let me explain. In your class discussion, you did something that scientists do all the time. You talked about how you can experiment to figure something out. How could you figure out what happens to a rock when it tumbles downhill? What are some things you could do? Maybe you thought about comparing the rocks that you find up here to the ones that you find down here after they roll down. That would let you see if the rocks at the bottom were different from the ones at the top. But it would be nice to see what actually happens as the rocks are rolling down. Well then, maybe you could experiment by rolling real rocks down the side of a mountain, like this. That looks like fun. It would be a lot of work. You'd have to find a mountain, you'd have to climb to the top, and it might be dangerous for anyone down below. This doesn't seem like the greatest idea. So maybe you thought about putting rocks in a can and then shaking them so that they bounce around, just like rocks rolling downhill. That's a great idea. We'll do something like that in class today. Except instead of using real rocks, we're going to use these, sugar cubes. Sugar cubes are hard like rocks, and they have sharp corners and edges, just like the rocks you'd find at the top of a mountain. So we'll see what happens to them after a little bit of shaking, and then after a whole lot of shaking. Are you ready to start the activity? I'm going to show you what to do step by step. Find a partner to work with. When you're done with this step, click the arrow on the right.
I'm your partner.
Get your supplies. Each group needs these.
All right, I have 5 sugar cubes. I've got our plastic container. I've got some markers. We've got a red and a blue. And you will not need a pencil because you're going to be typing your answers in. You also won't need the data sheet because you are going to be typing your answers in. But if you would like to open up the Google Slides that has, it's called the Sugar Shake data sheet. So you can type in your answers while I am your science demonstration partner. Here we go. I'm so excited. I love this lab.
Take a sugar cube and complete questions number 1 and number 2. You can draw the whole cube or just one side.
So we are also going to have to do some of this in our science notebook. So let's go ahead. I have to take this out of full screen. Let's go ahead and turn the page, and we are going to call this the Sugar Shake. If you don't have a science notebook, doing this on a separate piece of paper would be a fantastic idea because Mrs. Donahue and I are going to check and see that you did this page. So really simple. Count down 3 squares. 1, 2, 3. And draw a square. And you are going to label this square my sugar. Sugar is spelled with an A. Sugar cube. And you're going to draw another box. And then this is going to be a hypothesis. This is what you think it's going to look like. So my hypothesis, that is a scientific guess. So my hypothesis of what my sugar cube will look like after 200 shakes. And what do they mean by that? If I put my sugar cube into my plastic container, what do you think it's going to look like after I shake it? 1, 2, 3, 4, 200 times. So you are going to draw what your sugar cube looks like here in this one, and then you're going to make a hypothesis of what it looks like after 200 shakes. So here is the sugar cube for you to draw. Go ahead and pause your video if you need to. I guess I could turn a light on. It's kind of dark over here. Okay. Some more lights. Woo! Now it's nice and bright. You're drawing. I can't find my pause button, so you're drawing. Hope it's still recording.
Each of you choose one sugar cube and color the edges like this. As you do this, work over the plate so you don't get sugar everywhere. And you're just going to color 2 of the sugar cubes, not all 5.
All right, so this is my job, not yours. You just get to watch me. If you were in class, you would be coloring a sugar cube. I've actually never colored a sugar cube. I just watch you guys do it. So when your parents ask you what you did at school today, you can say, I watched my teacher color sugar. Okay. Now, get all the sugar off my marker. I have a whole new appreciation for making my students color sugar after this. Alright, I have both of my cubes colored.
Count how many edges a sugar cube has. Write the answer in question number 3.
Alright, so we have 1, 2, 3, 4 on this side. And we have 1, 2, 3, 4 around that side. And 1, 2, 3, 4 along the bottom. So 4 plus 4 plus 4. Go ahead and put that in your document.
Decide who will be the shaker and who will be the
I'm
counter.
the shaker and the counter.
You're going to switch roles after each trial.
Sorry, you don't get to do it.
This should only take 10 seconds to decide who's going to do each role. So decide now.
Me. It's me.
Shaker. Put one colored cube and all of the plain cubes in the container. Leave one colored cube on the plate. Close the container. Make sure that lid's on tight. Do the first trial now. Shaker. Shake the container 40 times, counting out loud.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Imagine a whole classroom of students doing this. It's so loud and so much fun. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40.
Shaker. Open the container and put the cubes on the plate. Both of you, write down how the cubes have changed.
All right, so on your Google, the lamp off, no glare needed. On your Google sheets, Google Sheets, you are going to write about how the sugar cubes have changed. What is different about them? Maybe you do need the lamp. Can you see? comparing these two. So look at how they've changed.
Counter. On the colored cube you shook, count how many edges have any color left.
1, 2,
Both of you
3,
write down the
4,
result.
5, 6, 7.
Shaker. Put the cubes you just shook back into the container. Make sure the lid's on tight. Switch jobs and finish the data sheets, including questions 5 through 10. When the class is done, discuss the question on the next slide.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That was 41. All right. So now you need to write how they've changed. I can't decide whether the lamp is good or not. Can y'all see? And if you're comparing, here's what it started out like. Okay, and let's count. 1, 2, 3. Let's see, we counted this. We got 3. All right, back in the container. This is trial number 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 40. I don't like counting above 20 for some reason. Okay. Compare. Here's what they look like. Oh my goodness. Here's what they used to look like. Let's count. We've got 1. Okay. This is trial 4. I should have written this down. Trial 4. 1, 2, 3, 4, 5, 6, 7. Woo! Some sugar dust. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. Let's see how they've changed. Okay, this is the one that used to have red on it. It has one little teeny dot of red right there. I don't know if you can see it. Okay, if this was our 5th one, I think it was the 4th one, but it's our 5th one. Here, you can draw what your sugar cube looks like now, down in that bottom box. Oh, actually, we'll draw it on our notebook. But I'm going to shake it one more time because I think that was only 4. So here we go. Sugar dust. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. They're supposed to be on the plate so I'm not getting sugar everywhere. I taste sugar everywhere. Ooh. Am I making you seasick yet? I'm trying to line it up. I am so sorry. So here is our sugar. We're going to draw another box over here. What my sugar cube actually looked like after 200 shakes. So you're going to draw a picture of your sugar cube. So this is what it looked like. This is what you thought it would look like. And this is what it actually looks like. You want to compare them? I am the worst Vanna White there ever was. Okay, go ahead and pause the video and take some time to answer these questions.
Discuss this question as a class.
There is a link for you to discuss this question.
Discuss this question as a class.
Discuss. Okay, so now your job is to go back into your science notebook and let's see here. See if I can switch cameras. Can't have this in full screen. Don't you all miss having me as a virtual teacher and watching me struggle? Okay, so you are going through your science notebook. So at your think at your wonder column of your See Think Wonder. So look at your wonder column and have you answered any of those questions by this mystery? Do you have any new questions that you want to add? Now we get to add evidence to our North American map. Observe the fossil layers below. Discuss what you notice about the layers. Well, if I'm looking at the layers, I notice that the oldest layers, the ones that are 14 million years ago, are on the bottom. And the youngest layers, the ones that are 2.5 million years ago, are on the top. And somewhere in the middle of that was the volcanic ash that had the animals that were found at the ash bed fossils. The fossils were found under a layer of sand and rounded rock. So there was sand and rounded rock on top of the fossils. Rounded rock. How do we think that the rounded rocks, where do we think they might have come from? I would love to hear your ideas. Where are mountains and rivers located around the Ashfall fossil site? So we now have another thing to add to our map. So last week we added our thick lava and our thin lava, and now you can add in the mountain ranges and the rivers. So go ahead and pause the video. I'm going to blow it up again so it's nice and big and you can copy it onto your map. Use the map to help you predict how the sand and rounded rocks formed a layer on top of the rhino bone. So now you're going to go back to your science notebook and find this page, and you're just answering the 3 questions, the same 3 questions you've been answering, but now you're answering them after you've watched Mystery 3. So how did the prehistoric rhinos and other animals die? You might have a different idea now than you did at the beginning, or you might still have the same idea. Why did it take 11 million years to find the fossils of the animals? You might have changed your idea. You might not have, but write your answer again. And then, how do you think the fossils were eventually found? Now that you've watched Mystery 3, do you have any ideas? So go ahead and pause while you fill this part out in your science notebook. Predict what changes in the land uncovered the fossils. So we're supposed to discuss with a partner. I'm going to have you type it into the Google Slides or the Google Forms. Follow the directions. And that is it. There are some other activities for you to do in Google Classroom, so please make sure that you have completed everything. Thanks for joining me today.